Hi, in the spread spectrum communication series, we are going to see about the categories of spreading sequence in this third class. Spreading sequence categories are PN sequence and orthogonal codes. For frequency hopping spread spectrum systems, PN sequence is most commonly used one. For direct sequence spread spectrum system, which are not employing CDMA technique, here also PN sequence is the most common one. For direct sequence spread spectrum system which employs CDMA system, we are using PN sequence and orthogonal codes for spreading. Next, we are going to see about how to generate the PN sequence. PN sequence generator produces periodic sequences that appears to be a random one. PN sequences generated by an algorithm using initial seed. In this, sequence is not statistically random but will pass many tests of randomness. What are the tests which are going to see is balance property, run property, autocorrelation property. In the next slides, we are going to see about the properties of PN sequence. Sequence referred to a pseudo numbers or pseudo noise sequence is called a M sequence. Unless the algorithm which is used to generate PN sequence and the seed which are used to spread the PN sequence are known, the sequence is impractical to predict and despread the sequence at the receiver side. The PN sequence is used to spread at the transmitter side is generated by linear feedback shift register. The block diagram of the linear feedback shift register is shown here. These are the important properties of PN sequence, which is balance property, run property and correlation property. Suppose we are generated a sequence using linear feedback shift register, means we want to test that the output of the linear feedback shift register is a PN sequence or not. How we are going to check whether the output of the linear feedback shift register is a PN sequence or not, means using these three properties: balance property, run property and autocorrelation property. Let us see about one by one. The balance property, that is property 1. If the generated sequence, that means the output of the linear feedback shift register, has 2 power n minus 1s and 2 power n minus 1 minus 1 zeros, means which satisfies the balance property. For example, the output of the linear feedback shift register sequence is 15, means we have 8 counts of 1s and 7 counts of zeros, means which satisfies the balance property. Okay, next one is a property 2. For a window of length n slit along output for n shifts, each n tuple appears once except for the all zero sequence, which satisfies the second property. The third property is called run property. In this, the sequence contains one run of ones, which is length n, one run of zeros equal to length n minus 1, one run of ones and one run of zeros is the length n minus 2, two runs of ones and two runs of zeros, which is length n minus 3, 2 power n minus 3 runs of ones and 2 power n minus 3 runs of zeros is of length 1. If these properties is satisfied, then the run property is also checked successfully. The last one is the autocorrelation property. The periodic autocorrelation property is also satisfied, means the generated sequence, that is the output of the linear feedback shift register, generates the exact PN sequence which is used at the spreading side. Thank you.